Hello guys and welcome to IGCSE on Fingertips. In this video, we are going to discuss the mole concept. As I've already said, this is a large concept and it is important. It carries a lot of marks in your syllabus. Let's quickly get started. During this lesson, I am going to take up some questions that are asked in your boards. I'm going to solve them and then there will be a video which will be of about solution of the entire worksheet that I have created for mole concept. Right now, this worksheet may be available only on our app, so please download app from the link in description or a pinned comment you will have in this video, and you can then get the worksheet, and if possible I'll upload a video solution of the worksheet as well. Let's get started. So we have reacting masses and mole concept. Now mole concept starts from the fact that the masses that are reacting, they react in a ratio always, right? This can be understood from Dalton's law that the materials react in a fixed ratio, or from the logic that mass or materials can neither be created nor be destroyed, right? It can only change the form. So carbon and oxygen can combine to form carbon dioxide. So things like that we'll understand through the chapter. Let's see now. So why do we study this reacting masses and mole concept? The most basic understanding is, let's say I am making a medicine, right? I want to make let's say aspirin, and I am trying to get the reactants to make aspirin. Now I need to know the exact composition of aspirin because it has to be a single compound. I need to know the exact amount of aspirin that a person gets in one tablet. Right now, you might also have seen sometimes when you break this tablet into half, your doctor might suggest you that take half of this tablet. The drug also is divided in half. So if the chemistry is wrong, you cannot take that half tablet. So to establish that, we need stoichiometry, we need mole concept. I'm sorry. So let's get started. So how does a manufacturer know exactly how much of each ingredient to use to make a medicine, fertilizer? How does an airbag know the right amount of gas to produce in a crash, right? So in airbag also we exactly need to know how much reactant must be there, which can be ignited, which can be reacted to produce a lot of gas. But then it should not be so much more that the airbag itself bursts, right? So that with that idea, let's get started. So stoichiometry study of relative amounts of substance involved in a chemical reaction based on the mole ratio in a balanced equation. Sorry guys. So we have the language of chemistry, formula and equations, the foundations. So in this is the idea that what is the division of the entire chapter. We have, first we'll understand the language of chemistry. I'll explain you how to write formula, how to form equations, and how to also balance those equations. In the foundation, we will understand how relative mass is used to calculate the mole, what is relative mass, what is mole, right? And what is of course their relationship, in which we will also see the Avogadro's constant, which is the number of particles in one mole. Calculation from chemical formula. So from the formula, what all can we calculate? We can understand the composition of a compound. I can exactly find out how much percentage of carbon is there in glucose, how much percentage of carbon is there in, let's say, ethanol, how much percentage of carbon is there in carbon dioxide. That can help me establish that if I find a new compound and this much percentage is there, can it be similar to that or not, things like that, right? Now special case was water of crystallization. This is a repeatedly asked question. Generally the value of x is 7. If you have already practiced this chapter or questions from this chapter, you might already know this, that you get questions in multiple where the value of x is 7, right? So we'll look at a few examples like that, and as I said, percentage composition. With it we will also understand purity and yield. Now calculations from chemical equations. What can we calculate from chemical equation? We can find out the masses of the reactant. We can find out which reactant will get over first. When it gets over, the reaction stops. that becomes the limiting reactant. Then we have calculation with gases and solutions. Now generally when reactions take place, it is not just solids reacting. We see that we generally dissolve reactants in water so that they can become ions, they can become free, they can travel, they can collide, and the rate of reaction can be increased basically, right? So that is why we'll need to understand how does solution work, and gases have a standardization according to their number of moles. We'll see in the chapter. So molar volume of gases, concentration of solutions we'll find out, and titration calculation. So from concentration, what all can we understand that is there in this. In conclusion and exam tips, I'll give you a small mind map where I will be able to tell you that you can go through this mind map. It does revise the major topics, and I will also tell you that what you should make sure that you do every time you come across a question of mole concept, right? So let's start with the chapter itself. So we have part 1 is language of chemistry, formula and equations. What does this mean? Let's see. So we have, the objective is to ensure students have the fundamental tools to write and balance the equation that are basis of all stoichiometry calculation. Now what I have done is, I have taken your syllabus from 2025 to 2027, and this objective is basically to tell you that sorry, the board wants you to understand these things. This is the idea that board starts with, that if I want child to know this, what all do I need to teach them? So we have, students have fundamental tools to write and balance equation. The first step to understand the equation and using them, before we can start equation, we must be able to write correct chemical formula. So writing the chemical formula becomes the first step, right? Now if I don't know how to write aluminium hydroxide or aluminium oxide, how will I show you the reaction of aluminium oxide as an amphoteric oxide reacting with an acid or with a base? So the first idea should be writing the formula. Now how do you do it? The first one is find valency. Let's look at a few examples. Okay, now find valency using group number. In group number, how do I exactly find the valency? See, it's a very simple idea, that if it is in group 1, 2, 3 and 4, the valency is also 1, 2, 3 and 4. Aluminium has atomic number 13, its configuration is 2, 8, 3, and it is group number 3, right? It is also period number 3 and group number 3. Now if you look at this, the aluminium atom wants to lose 3 electrons or gain 7 electrons in order to, gain 5 electrons, to attain the stable noble gas configuration, right? Now in this situation, its combining capacity, what is valency? Valency is basically the combining capacity. Its combining capacity is 3, right? So we will use valency for elements, right? And for ions that are known, these are the few ions that we already know, and you have to remember their valency and form compounds, right? One more such ion is OH negative, right? It has a charge of negative on it, which is -1. Now there are two logic to this. Okay, you can either cross valency or find logic. I understand this better with crossing the valency. Okay, let's see. So I said I should be able to find out the formula of aluminium oxide. So aluminium has a combining capacity of 3, and oxygen, it is in group 6. If it is in group 6, it needs only 2 electrons, which brings me to the second point, that if valency is 5, 6 and 7, you subtract it from 8. So something, not valency 5, 6, 7, I mean the number of electrons 5, 6, 7. So something has 5 electrons in its outermost shell, you consider that it has combining capacity of 3, right? 8 minus 5, because it will gain these 3 electrons or somehow share these electrons to get to 8, right? It does not want to lose these 5 electrons. So we subtract it from 8. 8 minus 5 will give you 3. 8 minus 6, which is the valency of oxygen, 2, 6, right? So oxygen has a valency of 2. It has 6 electrons in its outermost shell. Now when I write this over here, what I will now do? I will now cross the valency. Okay, let's see how do I cross the valency. I can simply write sorry, I can simply cross multiply these two, and what will I get? I will get Al2O3. This is the formula of aluminium oxide. I hope you understood this, but let me try it with one more example, and let's also take a few more examples where we can clearly understand the crossing method, right? So let's say that I have magnesium Mg, okay, and I am combining it with oxygen. Now, magnesium being in group 2 has a valency of 2. Oxygen, just we have found out that being in group 6 also has a valency of 2. Now, I told you there are two methods. I understand that method better, but I will show you one more method, and that will help you to establish formula of Mg. Then I will again balance this or make the chemical formula of Mg magnesium oxide using the other method as well. Let's get to it. Now, because this loses 2 electrons, it is plus 2. Because this gains 2 electrons, it is minus 2. Now, what happens is that how many oxygen are required to make a compound where the compound is neutrally charged? If this has a plus 2 charge, only one oxygen is required for each magnesium. So, I can write the formula is MgO. Every time you need to think that what can achieve a balance over here. So if we go back to aluminium, right, let me just erase this one. If we go back to aluminium, I can write that there are plus 3 over here, minus 2 over here. Now the balance is when aluminium has plus 6 charge and oxygen has minus 6 charge. That can happen when there are 2 of aluminium, 3 of oxygen. I hope this now makes sense. But also let's use the cross method to understand how to write formula of MgO, right? I'll write 2 and 2 over here. Now what you do is you will cancel out and find the lowest whole number ratio, which is 1:1, because when you are crossing over, you are actually finding the ratio in which they combine. If you want to find the ratio, you need to bring it to the lowest whole number possible. That is what ratio is, right? 2 by 2 is not a ratio, but 1 by 1 can be. So the formula becomes MgO, right? So this is how you find out formula. Now let us use this method and make formulas for a lot of other known compounds, right? What are we trying to discuss? We're trying to discuss formula for, let's say, let's combine all of this with, so SO4, just a second guys. Okay, so we have SO4 2 minus, NO3 minus, CO3 2 minus, and NH4 plus. Let's combine it with let's combine NH4 with all of them so you can understand it very clearly. I have NH4, which is 1. I have SO4, which is 2. So the formula becomes NH4 twice SO4. Okay. Now, if I wanted to write NH4 plus, right, or I'll write just 1 over here, and if you want to write NO3, I will write 1 over here. So the formula becomes NH4 NO3, right? As an assignment or as a practice, you can pause this video over here. Make formula for ammonium sulfate nitrate carbonate, magnesium sulfate nitrate carbonate, aluminium sulfate nitrate and carbonate, right? What I have done, I have taken a positive ion with 1 valency, with 2 valency, with 3 valency. I have taken negative ion with -1, -2 valency, right? This will also cover how many ever compounds you need to make. Only these are the difficult compounds. You can try the same method and find out the formula for aluminium hydroxide. You will and you should find it to be ALOH thrice. Let me know in the comments if that is the answer. Now, once you know how to make each formula, now you should be able to write down and balance the equation. But how do you balance the equation? There are a few things that you need to always remember. Why to balance the equation and then how to balance it. Why to balance the equation? Because matter can neither be created nor be destroyed. If that is true, then on both sides the number of oxygen, the number of carbon, the number of reactant should be equal to the number of product, right? If that makes sense, let's understand. So how do we write it? From word equation we first find the correct formula. We've just understood how to write the formula, so I think that should be good enough for you. After that we should count the number of atoms on each side and then balance with the coefficients, right? With this, whenever they ask you in your exam an equation where it carries more than one mark, the general idea is to write the correct balancing. Okay, the next mark is generally for balancing. This will also become very useful when you are writing ionic equation. I'll also show you ionic equation in this chapter, but more about ionic equation can be understood from redox and electrochemistry video that is already on YouTube. Right, now importance of state symbols: solid, liquid, gas and aqueous. Atoms conservation and mass conservation is something we will look at to establish a balanced equation. Now there are two balance equations that I have taken as exercise to solve over here for us to understand this concept. So make and balance equation for combustion of ethanol. First I'll tell you that when ethanol combusts, what is the word equation, and then we'll go through how to find out the balanced equation. So when ethanol combusts, it forms carbon dioxide and water. For combustion it requires oxygen. So first let us write this equation. We have C2H5OH, right? This is ethanol. Okay, then you have O2, right? This gives you CO2. As I've said that the word equation is carbon dioxide and water. Now I will take this opportunity here and show you why carbon oxide for that matter is CO2. Okay, so carbon has a valency of 4, right? Oxygen we know now that it has a valency of 2. In cross method what I can do, I can make this ratio which translates to CO2. So the method I have shown works for ionic compound, electrovalent compound or covalent compound as well. It also works for giant covalent structure. Silicon SiO2 comes from the same logic. Silicon has a valency of 4. It is just below carbon, and oxygen still has valency of 2. Right? So you can use those logic to find out any formula. Now, I have taken this example thinking that this can never be found out using that logic, because that is a part of organic chemistry. You can go to the video of organic chemistry, find out why ethanol is C2H5 and OH. This type of formula, the organic chemistry formula, can be better understood by understanding organic chemistry rather than by understanding how formulas are made. Okay, with that being clear, let us understand over here that C2H5OH plus O2 gives CO2 plus H2O. Let's first balance this. To balance, what do you have to do? You have to find out the reactants and the products elements, right? So there is carbon, hydrogen and oxygen. These are the three reactants I have. Carbon is 2, hydrogen is 6 and oxygen is 1 plus 2, 3. Now let's look over here. Carbon is 1, hydrogen is 2 and oxygen is 3, right? Oxygen will not stay balanced for a very long time as far as I understand this question, but let's start with balancing. Okay, now there are 2 carbon over here. I have to make carbon 2 over here. There is only one option. You have to write this number here. Now understand and remember guys, when we are balancing, there is only one place where you can write your balancing number, and that is over here. You cannot write it over here. because now if you know how to make formulas, you also know that if I write a 2 over there, it changes the ratio in which carbon and oxygen combines. So I need to write that 2 over here, right? With that clear, this now becomes 2, but oxygen now becomes 4. Okay, we will balance oxygen at last because alone oxygen is available to balance, right? So intuitively what you should think of is something available in its element form. If it is, it can be balanced in whatever form you want, and therefore what I will do, I will not balance oxygen without balancing the hydrogen and carbon first. Now there are 6 hydrogen. To balance that, I'll have to multiply this over 3. So I will get hydrogen is 6, but now oxygen is 3 plus 4, which is 7. Correct? Now oxygen is 7. Now what was my aim? My aim was to balance this because it was available only in element form. But look at this. Out of the 7 oxygen that I want to balance, 1 is already present over here. So how many more are required? 6. I can easily write 3 over here. What will this make? This will make the whole equation balanced. 3 2s are 6 and plus 1 7. On both sides you have 2 carbon, on both sides you have 6 hydrogen, on both sides you have 7 oxygen. That balances the reaction. But we have one more reaction to balance. Combustion of ethanol is balanced. You have calcium hydroxide with hydrochloric acid, right? I hope that is visible. Now, how do I balance calcium hydroxide? So first I need to establish the formula of calcium hydroxide. I have Ca, which has a valency of 2. I have OH, which has a valency of minus 1. So I have CaOH twice, right? With hydrochloric acid. Hydrochloric acid is hydrogen and chlorine. This is plus 1 and minus 1, so it forms HCl. But now, what are the compounds that form? This is a base, this is an acid. The compound that forms are salt and water. If I remove the hydrogen and oxygen, I am left with calcium and chlorine. But how do calcium and chlorine combine? So I have Ca and Cl. This has a valency of 2 and 1. So the compound should be CaCl2. Now, the more you practice, the more you will be able to write formulas without actually writing this down, right? I might be able to do this right now without writing all of these things down. You will be also able to do that if you practice enough. In the worksheet, you will find enough practice to do that. Now, let's balance this reaction, and for that we need to understand what is imbalanced. Calcium is 1 over here, calcium is 1 over here. Oxygen is 2 over here, hydrogen is 3 over here, 2 in this and 1 in this, and chlorine is 1 over here. Oxygen is 1 over here, hydrogen is 2 over here, and chlorine is also 2 over here. Now nothing is available in its elemental form. So what I'll do, I know that chlorine is already 2 over here. There is no other option for me to write a 2, right? I have to, because if I want to increase the number of chlorine, I'll have to write a 2 over there. So as soon as I do that, hydrogen becomes 4, right? 2 plus 2, 4. So this also changes, and over here this also changes, but that hydrogen can be easily balanced. How do you do that? Write a 2 over here. So now this becomes 4, this becomes 2. Now match everything. Calcium 1, oxygen 2, hydrogen 4, and chlorine 2. Now what generally happens is, you might think that, okay sir, you know how to balance this, so you started with the right element. How to pick the right element? I picked chlorine because I have to write a 2 over there. Everything else comes from the fact that I first identified which needs to be balanced, right? You might think, sir, you could have started with hydrogen, but hydrogen is available in 2 places over here. If I start with hydrogen, the first answer I'll have to answer, the first question I'll have to answer myself is, which of these compounds do I start the balancing with? So start with something it is clearly visible that this has to be done. and then you will find a chain where you keep on solving it and you will find the answer, right? So this was the basic first chapter. From here we have understood how to write formula, we have understood how to balance equations. Now the rest of the chapter should become easier. Okay, so now we will go to the second part of this discussion. It is the foundation, relative masses, and the mole. So, foundation meaning the basis of this chapter. From where does this chapter come, and what is the most important part of this chapter? The most important part is relative mass and the mole concept itself, right? Let's see. Reaction works in ratio. How? Look at the equation above, and what else do you have to do? What does it say? And use balancing coefficient to see. So if I have written something like this, then I think we should focus again. So reactions work in ratio. Now look at this very carefully. Can I say one molecule, right, of ethanol requires 3 molecules of oxygen to combust to form 2 molecules of carbon dioxide and 3 molecules of water. Now, instead of molecules, I will be able to establish that why is it easier to use this terminology, that it is the basis of mole concept, the basis of parts. Okay, I'll repeat this again using a different word. One part of ethanol requires 3 parts of oxygen to produce 2 parts of carbon dioxide and 3 parts of water. You can pick any balanced equation from anywhere on internet, from your textbook, from your IGCSE A-Level textbook. You will always find that a balanced reaction will tell you the same story. Now let me repeat it using something more that can help you understand this, right? So what do I have here? I have C2H5OH. If I wanted to react two two molecules of C2H5OH, I will require 6 of O2. That is the balancing. We've just established balancing, right? If I multiply one of the reactant with a whole number, I have to multiply the whole reaction with that number. What does this mean? It means that the simplest ratio in which these reactants have formed products, or in which these reactants have reacted, it always remains the same. What is that ratio? That ratio is 1:3, 2:3, right? And all of them are in ratio. One ratio of ethanol. One ratio of ethanol produces 2 parts of carbon dioxide. If I ever wanted to use 2 parts of ethanol, I will have to get, or I will get 4 parts of carbon dioxide. Only then this reaction is balanced. And if we truly follow the logic of conservation of mass, this will keep on happening. This ratio will repeat itself in this reaction with whatever mass of each of them you take, right? For that matter, also let's have a look at our other equation. In this, I can write 1, 2, 1 and 2. So one part of calcium hydroxide always produces 1 part of calcium chloride. 1 part of calcium hydroxide always produces 2 parts of water, right? Sorry. Now you might be thinking, why am I calling this as parts? To understand that, I think I have explained it later again, but here we can try that out. So I'll just erase this balancing part first. I hope that is understood by all. And let's really understand, why do I call it parts? Why? So for this we will need to find out the relative mass of calcium hydroxide. And let's first understand what is relative mass of calcium hydroxide. What is the relative mass? Relative mass is the mass of atoms compared to 1/12 of a carbon atom, where the mass of carbon 12 atom itself is 12 grams. Now, this seems a little bit difficult. So let's have a look at these balances. Okay, so these are a few balances that I see which can help us to understand what this balancing is. Now imagine that I assume that carbon 12, this is the isotope of carbon which has a mass number of 12, or it has 12 nucleons, right? So that is carbon 12. If I take carbon 12 on one side of this balance, I require 12 hydrogen to balance it completely. Okay, I require 12 hydrogen to balance it completely. What is the mass of this carbon 12? The mass of carbon 12 is 12 gram. Can you establish what is mass of one hydrogen? The mass of one hydrogen is 12 divided by 12, which is equal to 1 gram. Right? Now, this can be done with anything actually. I can take helium and I can balance it with hydrogen. I can take hydrogen and balance iron with it. But we have taken carbon 12 as our central ratio. We have taken it as a standard. Right? Chemists have decided that we'll always compare all the masses with carbon 12. So, in this manner, when you see, right, the nucleon number, it is generally the mass number. Why do I say generally? Because with chlorine the mass number is 35.5 and its relative mass is also 35.5. I hope you already know that how does isotope work and why do we take weighted average of all the isotopes, right? But for chlorine it's 35.5. Basically for chlorine the mass of 1 mole of chlorine is 35.5 gram. Okay, it's not one atom which is 35.5 gram, it is actually 1 mole of chlorine which is 35.5 gram. But before you get confused about that, let me come back. What is the idea you need to get from here? That mass, which is relative, right? Why is it relative? Because this is not the actual mass of hydrogen atom, right? It is mass of hydrogen relative to the mass of carbon. So I call this relative mass. If the mass is of just an atom, I call it relative atomic mass. If the mass is of a molecule, right, water, I call it relative molecular mass. But if it is mass of some ionic compound, I call it formula mass. Now, why do I need to call it formula mass? Because for an ionic compound, we know that it forms a giant lattice. And this formula is nothing but the ratio of number of atoms of each of the element forming that compound. Now, if I just have the ratio, I cannot say that this is the mass of the lattice. So, I will say from the formula, the information I get, this becomes its mass. So let's find out the mass of calcium chloride. Calcium has a relative mass of 14, chlorine has a relative mass of 35.5, and there are two of them, so I have 71 plus 40, which is equal to 111 gram. So calcium chloride has a mass of 111 gram. The formula mass is 111. With same logic, water has 2, or rather let's write it as 1 into 2 plus 16, right? Oxygen has relative atomic mass of 16. Hydrogen has relative atomic mass of 1, but then I need to multiply it with 2 because there are 2 hydrogen in this compound, right? So like this we can find relative masses. Now I think we can go back to our discussion about how these all are reacting in ratio. Just a second, guys. Where were we? Yes, over here. Okay. So let's understand this again. What I was saying. Let's find out the relative masses of each of them. Okay. relative mass for calcium you have 40. You will always have periodic table in all of your tests, ideally in your school and for sure in your board. So you don't need to remember these values. After a lot of practice, I expect that the kids I teach remember these values. I hope you also remember these values with a lot of practice. So let's get to it. So you have 40 plus 16 plus 1, right? 16 for oxygen, 1 for hydrogen, and there are 2 of both. So this will give you 16, 17 twos are 34, 34 plus 40 gives you 74 gram. This is the relative mass of calcium hydroxide. Okay. Now let's move this a little bit towards that side. Okay, doesn't get moved. So sorry guys, I just lost that. So let's now find out for HCl. It should be 35.5 plus 1, which will give you 36.5. This is the relative mass of HCl. Now you might be thinking, do we multiply this 2 with this 36.5 or not? No. Right now, when we are just finding the relative mass of HCl, you don't need to. But when we want to find out how much of HCl combines in this equation with calcium hydroxide, at that point you need to. Okay, so 36.5 is the relative mass, but whole thing multiplied by 2 will give you how much of it reacts. So 36 into 2 is 72 plus 1, 73 gram. Okay, now you can again find out for calcium chloride. I think we just found out that this was 111 gram, and we can find out for water it is 2 plus 16 into 2, right? So 18 is its relative molecular mass, but multiplied by 2, how much water do we get? So 18 twos are 36, right? Now, as simple logic, the addition of these two should be equal to addition of these two, right? Matter, mass can neither be created nor be destroyed. So this should be 147, and this is clearly 147 gram, right? I hope you got this calculation, right? Because now I will start to find ratios and explain you ratios with the help of these masses. Okay, so I will write the reaction again. The reaction was calcium hydroxide reacts with HCl to produce CaCl2, calcium chloride, which is a salt, and water, right? This is a neutralization reaction. Here the standard mass, right, the relative mass is 74, 73, 111 and 36. Now let's get to the part where I was talking about ratio. Okay, let's take, okay, right. Now what do I mean that they will always react in ratio? I mean to say that if you take 7.4 gram of calcium hydroxide, what I did, I divided 74 by 10. If I take 7.4 gram of calcium hydroxide, I will require 7.3 gram of HCl for sure, because if this ratio is set and established, there is no way I require any other masses, right? I will elaborate on that in just a second. So I will get 11.1 gram of calcium chloride and I'll get 3.6 grams of water. What I did, so let's say 74 gram is one part of calcium hydroxide. Now I am taking 0.1 part of calcium hydroxide. How much HCl will I require? I will require, if this is 0, this is 2 parts, right? I will require 0.2 parts. So this mass divided by 10. Now, if this is one part of calcium chloride I get from one part of calcium hydroxide, or one part of calcium chloride that I get from 2 parts of hydrochloric acid, then I will always get 0.1 part if I use 0.2 of that, or if I use 0.1 of that, right? I hope that is understandable to you, and the same goes with water. So this can be established about masses, that they always react in a ratio. You can pick up any reaction, and this ratio, once established for any reaction, always follows. Now something to understand over here is a lot of kids get confused about the fact that moles are not conserved. These ratios are not conserved. Okay. I think I already have a topic for that. Let's wait for it. If I don't find it in the explanation, I'll cover that at the end of this discussion. Right? Now, mole and its link to mass. Okay, what does it say? It says that 1 mole of a substance has mass in grams that is numerically equal to mr. And I think I already said this once, that CaCl2, we found out that it is 111 gram. I said that 1 mr is nothing but 1 mole. I was saying that 1 mole of substance is its mr, right? 111 gram is not actually 1 atom of calcium chloride. Does it make sense to you? It should be obvious, right? 1 atom, or 1 atom of calcium and 2 atoms of chlorine, they will not have a mass of 111 gram. It is too much, right? Atoms have mass in order of 10 to the power minus 27 kilogram. So mass of one atom is very less. So the relative mass, we have found out, it is the mass of 1 mole of that substance. In fact, I can write N is the number of mole. It is the mr, the relative mass, right, divided by the measured, sorry, I am writing this ratio incorrect, measured mass upon relative mass. The number of moles is equal to the ratio of measured mass upon the relative mass. Let me explain this. If I had, let's say, 55 grams of calcium chloride, okay, not even 55, let's take a simpler ratio that can be done mentally. So I have 11.1 gram of calcium chloride. How many parts of calcium chloride do I have? 11.1 upon 101, which is 0.1 parts of calcium chloride I have. Because if we consider 111 to be 1 part, then 11.1 is just 0.1 of that, right? Now that 0.1 is not parts, it is actually mole. Okay, so what is mole again? Mole is measured mass upon relative mass. That relative mass can be any of the following: relative atomic mass, relative molecular mass, or relative formula mass. For that matter, if I have 50 grams of let's say magnesium, okay, then the number of moles of magnesium I have is 50 upon 23. Why 23? Because 23 is the AR, the relative atomic mass of magnesium. 23, or I think 24, right? So you can easily find out the number of moles using this simple formula. And for a fact, you can easily make a formula triangle, that N is equal to small n. Small n stands for the measured mass, and mr stands for the relative mass, right? So you can make a formula, that N, formula triangle I mean, mr and m over here. So the mass, if I want to find out the measured mass, I need to multiply the number of moles I have into the relative mass. Let's say someone tells me I have 0.5 moles of calcium chloride. So what I'll do, how much mass does that person have? 0.5 multiplied by 111, which gives me 55.5 grams, right? 555, yes, 55.5 grams of calcium chloride they have when they have half mole of calcium chloride. So the parts that we were talking about, the ratios that we were talking about, it is nothing but the mole. The ratio is nothing but mole. Now if we want to find out the number of moles using calculations and equations and balancing, we need to now remember everything that we have understood so far. And in this, we need to remember just one more extra point, that 1 mole of particles is 6.02 into 10 to the power 23 particles. Now, just like I said, that 1 mole of calcium chloride, right, it will in its lattice contain 6.02 into 10 to the power 23 particles of calcium chloride. But how many chlorine atoms will it contain? It will contain these many multiplied by 2, right? Let me erase everything else and I'll just explain it to you. You can go back in the video and write down the notes if you were writing at all. I will try and make this sheet available for you to download it and make your own notes. Okay. So, 1 mole of calcium chloride contains how many atoms of calcium? How many atoms of calcium? It will contain 6.022 into 10 to the power 23 particles of calcium. But how many particles of chloride ions? It will contain this multiplied by 2. Why? Because each part of calcium chloride, each unit of calcium chloride contains 2 of chlorine. Now let's take another example. If they have given me, let's say C6H12O6, they're saying that we have 1 mole of glucose. I think this is glucose, right? What is the mass of this 1 mole? Let's find that out. The mass of 1 mole is 6 into 12 plus 12 into 1, where this second number is the relative atomic mass and the first number is number of atoms of that thing. So again 6 into 60, right? Oxygen has mass 60. This will be 6 into 12 is 72, 12 into 1 is 12 and 16 6 are 96. So 9 and 4, sorry, 9 and 4 is 10, 10, 11, 11 and 7 is 18. So if you have 1 mole of glucose, C6H12O6, you have 180 grams of glucose. In this 180 grams of glucose, how many carbon atoms are there? The number of carbon atom is 6.02 into 10 to the power 23 into 6. How many hydrogens are there? 6.022 into 10 to the power 23 into 12. How many oxygen atoms are there? Again 6.02 into 10 to the power 23 into 6. Right? But if someone asks you, what is the number of molecules in 1 mole of glucose, then it is exactly 6.02 into 10 to the power 23. That is the number of molecules of this whole unit, right? So this particle becomes a term where you have to understand what they are asking. They can ask you how many atoms of carbon are there in 1 mole. They can ask you how many ions of chlorine are there in 1 mole, right? And they can ask you how many molecules of this thing are there in 1 mole. So you have to read the question carefully. When they say particles, they can replace it by ions, atoms and molecules. You have to find out which they are talking about and then answer the question. Okay? If that is clear, can you do these things? I have already taught you how to find the relative mass. This 30 gram is the measured mass, right? We were using the formula measured mass upon relative mass is the number of moles. This 30 is measured mass of this NH2 twice CO. 40 is measured mass of CaCO3 and 45 is the measured mass of C6H12O6. Now, can you find out the relative masses? Take 30 in numerator, the relative mass in denominator, and tell me the number of moles in each of these examples, right? As an exercise, you can also find out the number of atoms or the number of ions of each element in these things. So let's do one of them for our example. So glucose has relative mass of 180. Measured mass of glucose in our example is 45. Okay, so can I write, let's erase this space, let's find some space over here. Can I write that for glucose measured mass is 45, relative mass is 180? So I will find that the number of moles is 1 by 4, which is equal to 0.25 mole. Okay, if I have 0.25 mole of glucose atom, right, then how many atoms and how many moles of each, sorry, I have 0.25 moles of glucose molecule, how many atoms and how many molecules of each of them exist? Okay, let's understand that number over here. So in 0.25 mole, the number of glucose molecules, okay, is equal to 0.25 into 6.02 into 10 to the power 23. If you want to find oxygen atoms, it is, there are 6 oxygen atoms, so it is 0.25, that is the number of moles. Now the moles of oxygen atom is 0.25 into 6, right? And the Avogadro's number, or the, I should not write Avogadro's number over here, the number of atoms of oxygen is, this should be 3, right? No, not 3, I think 1.5. So the number of atoms is 1.5 into 6.02 into 10 to the power 23. If I do the same thing for carbon, it will be same. It will be 0.25 into 6 because there are 6 carbon again, and the number of atoms will be again 1.5 into this. And it is obvious that if each unit contains equal number of oxygen and carbon, then in these many molecules, the number of oxygen and carbon is going to be same. Moving on, number of hydrogen, right? So for hydrogen, I have 0.25 multiplied by 12, right? 12, so this will give you 3. The number of atom is equal to 3 into 6.02 into 10 to the power 23. But this does not break the logic that the number of glucose molecules is still this much. It is still true, right? I hope this makes sense to you. If you have any questions, you can comment down in the comment box, right? I will try and answer every question. If there are too many questions regarding this, I'll try to make a short video or take a announce short live. Now, if that all is clear, let us understand calculations from chemical formula, in which I am also going to show you that moles may or may not be conserved. So what do we have here is, we will first understand empirical and molecular formula, and after that we will reach a point where we will be able to take equations and then answer them. So what is empirical formula? Empirical formula is basically the smallest ratio we can say where these elements have combined, right? So in case of glucose that we just saw, it was C6H12O6. The minimum ratio in this, in which these things combine, is going to be CH2O, right? 6, 12 and 6 have an HCF of 6. So I can write it as CH2O. This is the ratio in which they combine, right? This is the ratio in which, just a second guys. Okay, this is the ratio in which they combine, right? But this does not essentially mean that I know the exact formula. So there will be a small step to establish molecular formula from the empirical formula. But let's look at the type of questions they give us, and the answer lies in this 4-step method. So the first method we will see just here. You can read the question that X contains, a compound X contains carbon, hydrogen and oxygen only, and in this compound, right, just a second guys. So I was saying a compound X contains carbon, hydrogen and oxygen only. Yes, Okay, X contains 54.54% of carbon by mass, 9.09% of hydrogen by mass, and 36.37% of, I'm guessing, oxygen by mass. Now we are going to follow this method where I'll find the mass percentage, find the moles, divide by the smallest number, and we'll find the exact ratio. Now if you are able to see this diagram, it also tells you the same story. It's trying to tell you find the masses that combine by experiment, change grams of to moles of atoms, and this tells you the ratio in which they combine. Now let us find this 4-step method, and let us also understand using the example that we have, right? Let's zoom. Okay, perfect. I hope this is visible properly. So what do you have? You have that you have 54.54 percentage. Remember that this is percentage. Okay, you can also have mass. You can start with mass also. I'll show you that in this example itself how to do that. 9.09 percentage and 36.37 percentage, as I suspected. Of course, they have given about oxygen. Now instead of percentage, if I start by writing, if I have 100 gram of compound, okay, because percentage is 100, I can say 100 gram of compound, which would mean I have 54.54 gram of carbon, 9.09 gram of hydrogen, and 36.37 gram of oxygen by mass. Now, when they say by mass, I can divide by the relative mass. What will I find? The first step was from mass percentage to mole. So I divide by the relative masses, which will give me the number of moles. Okay, let's do that. So we have 54.54 divided by 12, which will give me 4.545. Okay, try to write 2 or 3 significant figures. It will help you understand your answer better. 9.09, and we have 36.37 divided by 16, which will give me 2.27. Now identify which is the smallest number. What is this? This is the number of moles of each element in the compound. This can tell me the mass of each element in the compound, or from mass I can sorry, I can find out the empirical formula, the ratio in which these elements have combined. So what I'll do, this 4.54, everything, because I want a ratio, I will divide by this smallest mole number I have. Okay, so 4.545 divided by 2.27 gives me 2.002. So I will take that as 2. Then 9.09 divided by 2.27 gives me 4.004. So I will take this as 4, and of course this will give me 1. So the combining ratio is C2H4O, right? So now let's look at the question again and let's establish our method. So the question says the question says calculate the empirical formula of compound X. They have given you the percentage. So first is always present. Then we converted it to moles. So we have 4.545, 9.09 and 2.27 is the number of moles. We divide by the smallest, right? And then we establish the ratio, right? I hope this method is clear to you. Now, let's see what's next. From empirical formula, you generally can find out the relative, the molecular formula if you have the molecular mass. Now consider this very simply, that there will be empirical mass of this compound as well, right, which will be 12 into 2 plus 1 into 4 plus 1 into 16 into 1, which will give me 24 plus 4, 28, 28 plus 16, 42, 28 plus 16, 44, I think, right? Correct. Now compound X has relative molecular mass of 88. What does that mean? It means that when I write it in this form, CXHYOZ, it gives me 88 grams. If this value gives me 44, what of these values will give me 88? It's easy to find out. See, instead of thinking about it like this, you can also find out that this means that the molecular mass upon empirical mass gives you a multiplier, right? This is the actual number of atoms of each of the elements present in the compound. So I have 88 upon 44. Also consider this an important formula. So you have to multiply 2 with each of the number of atoms. That will give you, let's write it over here only, C4H8O2. This is the actual number of atoms of C carbon, H hydrogen and O oxygen in the actual compound. So if you have molecular formula, you can find out empirical formula. If you have empirical formula and molecular mass, you can find out the molecular formula as well, right? Let's see what is next in this topic. In the understanding of mole concept, as I told you, that we have found out that there are a lot of special cases where water of crystallization, the value of X generally needs to be found out. Now in this, it is important to remember the colors of crystal. Sometimes a follow-up question is there, what will be the color of crystal if you dehydrate them, right? So two colors, the most important colors according to me that you have to remember about the colors of crystal is white copper sulfate is anhydrous. It is without water, but when it has water, it becomes blue. So in this method, when you heat copper sulfate or try to remove water from copper sulfate, you will find that its color goes from blue to white. Similarly, for cobalt, blue is anhydrous, pink is hydrated. So if you go on heating a hydrated copper cobalt salt, it will go from pink to blue. Okay, here you can consider blue as the linking part where you will be able to remember this. So copper sulfate is blue when hydrated, cobalt chloride is blue when anhydrous or without water. If that is clear, let us do a question. It will be very easy for us to follow the steps given, considering that we can find the relative molecular mass, we can find the number of moles, we will be easily able to establish the water of crystallization ratio, right? Question says magnesium sulfate crystals are hydrated. Another student heated some hydrated magnesium sulfate crystals in crucible and obtained following result. So mass of hydrated magnesium sulfate crystal is 4.92. So with water it's 4.92. Mass of water removed is 2.52. What is the number of moles of water removed? Simple. Number of moles is measured mass upon relative mass, right? So let's take measured mass. Measured mass is 2.52. Let's take relative mass. So relative mass is H2O, which will give me 2 plus 60, which is 80. Quickly in my calculator, I can find out 2.52 divided by 18, which is 0.14 mole. Calculate the number of moles of anhydrous magnesium sulfate remaining in the crucible. The MR of anhydrous magnesium sulfate is 120. So they have given how much was there when it was hydrated. They have given how much water is removed. So the measured mass is the difference between these two. I have 4.92 divided by 2.52. So quickly 4.92 minus 2. This will give me 2.4 gram. And then they are saying find the number of moles. How do I do that? I will again use the formula that number of moles is equal to measured upon relative. Measured is 2.4. Relative they've already given you, it's 120. So 2.4 divided by 120 is going to give you 0.02. Now calculate the ratio of moles of anhydrous magnesium sulfate is to moles of water. So anhydrous magnesium sulfate we have found out 0.02. is to number of moles of water we have found out 0.14, right? 0.02 and 0.14. What is the simplest ratio? Whenever they say ratio, whole numbers are required. 1:7, right? How many water molecules are there per one crystal of MgSO4? 7. So 1:7 is your ratio. How do you suggest the formula? You simply write 1 MgSO4 dot 7 H2O. Right? As I said, they really like this number 7. A lot of times 7 is repeated. Now, in the next part of this discussion, I hope this is clear, guys. There can be a lot of questions, but they are just variation of this one type of question. Right? Now, percentage composition, purity and yield. Now, in percentage composition, we can consider it to be inverse of empirical formula. Now, see, empirical formula, what did I do? I found out ratio of the moles and then I suggested a formula. But I can simply find out the percentage composition using a very simple question. How many percentage of nitrogen is in 12 kg of ammonium nitrate, right? Let's look at this and let's quickly find out the answer. So, let's take some working space over here. What they have said, ammonium nitrate. Nitrate is NO3 minus ammonium is NH4. If you remember, I have already made the formula when I was explaining formulas that NH4 NO3 is your compound, right? That is 12 kg of NH4 NO3. Let's find out what is the mass for this. We have 14 plus 4 plus 14 plus 16 into 3. 16 3s are 48, I think. 48 plus 28 plus 4. 4 plus 48 plus 28 is 80. So 80 grams of NH4NO3 is there. In this 80 gram, what is the mass of nitrogen? The percentage of nitrogen is 40 plus 40. The mass of nitrogen is 28. Okay. So, in 12 kg, if 80 gram is in, sorry, I should have written it like this. If 28 gram is in 80 gram of the compound, how many in 12 kg is 12,000 gram? But if you understand percentage properly, the answer 28 upon 80 is going to be equal to question mark upon 12,000, right? So I don't even need to consider the 12,000. That is just a redundant information for at least this question. So 28 upon 80 into 100 is the percentage of nitrogen in this compound. 28 upon 80 into 100 gives me 35 percentage. 35% by mass. The compound has nitrogen. Now, what is purity? If you understood what is percentage composition, also see, I'll just extend this and can I say the percentage of hydrogen is 4 upon 80? The percentage of oxygen is 48 upon 80. All of these percentages are going to be equal to 100 because the compound is sorry, 100%. Now, in this case, what I want you to remember is this is just the starting of empirical formula. Now I can take these percentage masses and establish empirical formula, right? That can work out. I will need, see, this is how much, right? Quantitative analysis, in other words. You have paper 6, question 3 is your qualitative analysis where they ask you what is what. So, with all of the understanding of this chapter, it is very easy to find out how many atoms of nitrogen, how many atoms of hydrogen, how many atoms of oxygen may be present in this compound. But there is no way with just mathematics to understand that what compound is without doing some experiments. That is what is known as qualitative analysis. What is it? This is how much is it. Okay. Now let's get back to what I was explaining. So we have, if this nitrogen comes from air that has only 71% nitrogen, how much air will be required? And this is a purity logic question. Now, what I am saying is, or what the question is saying is, that this nitrogen, percentage of nitrogen, but to find out how much of air is required, I need first the mass of nitrogen. 35% of 12,000, right? That is the mass of nitrogen. So I have 35 into 12,000 divided by 100, which is 4200. Now they are asking, where do I get this nitrogen? I get this nitrogen from air. Air has only 71% nitrogen. Okay, let's say it's 78, 21% oxygen, right? So 78%, the purity of air for nitrogen is 78%. That can be said, right? Out of 100% of the air, nitrogen is only 78%. So if I extract nitrogen from air, I expect to get only 78% of nitrogen, right? Now the question is, let's erase this. The question is that if only 78% of air is nitrogen, how much air is required? Now let's calculate it like this. Let's say the total air is x grams. 71% of this x gram is equal to 4200 grams. Correct? Can I write this? 78, sorry. Can I write it like this? Or in other words, what will be purity now? Pure of mass of pure product, mass of impure sample into 100. So if I write that pure is 4200, okay, instead of this, if I start with the logic of purity itself, just the purity. So 4200 is the mass of pure product. Mass of impure sample, I don't know. I require mass of impure sample to be found out. Into 100 should be equal to 78, because purity of nitrogen in air is 78. Can you simply find the value of x? This can be written as 4200 upon 78 into 100 is equal to x. So 4200 into 100 divided by 78 gives me nearly 5384.61. So nearly 5.4 kg. Can I say I will require nearly 5.4 kg to get 4200 grams or 4.2 kg of nitrogen. I hope this makes sense, right? After we have understood this, there is also something known as yield. Yield works very similar to purity, because see, mass of pure product upon the mass of impure sample, in other words, actual yield upon theoretical yield. Now what happens is sometimes the process is a little bit inefficient, right? So I am burning coal to produce carbon dioxide and water. I will require oxygen for that. But I take 10 kg coal, out of which, even if all of it burns, I find out that only 98% of the required carbon dioxide was produced. Then that 98% is the yield. How can that happen? That can happen due to a lot of reasons. One of them is purity, other is efficiency of process. What if the coal that I said has burnt has not actually burnt? Some of it contained moisture in it, and because of which it bursts on expanding and it has flown as ash. It has not burnt only. Then in that case I will not get that much carbon dioxide, and that becomes the yield of the process, right? How much output do we get, right? So that is percentage composition, purity and yield. And guys, now is where we get into most of the questions. Most of the questions are asked from here. So we have reacting masses, we have limiting reagents, we will find concentrations, we will find volume and everything, right? Let's quickly understand this topic, right? We have a small footbridge understanding as well, right? Let's get to it clearly. So what do we have? Ammonium nitrate. Okay, so I think I had made a question over here connecting the previous part. Okay, so nitrogen comes from air only, right? We are talking about this ammonium nitrate. Ammonium nitrate can dissociate on heating into gases nitric acid and ammonia. So nitric acid also is released as gas. It is at that temperature. Ammonia is also gas. If 2.295 kg of ammonia is formed, what is the yield of process? So I think this question should have been above this, but let's find out the yield. Okay. So I have ammonium, sorry, I have ammonium nitrate, right, which decomposes to form nitric acid and ammonia, and this reaction is balanced. There are two nitrogen, four hydrogen, right, three oxygen. So 12 kg of this dissociates and 2.295 kg of ammonia is formed. What is the yield of process? Now, taking simply 1 is to 1 is to 1 is the ratio of the reaction. So 1 mole of NH4NO3 should produce 1 mole of NH3. Let's find out how many moles of NH4NO3 are there in 12 kg. We know that the mass of NH4NO3 is 80. So I have 12,000 divided by 80. This will give me the number of moles, right? 150, I think. Yes. So I have 150 moles of ammonium nitrate. How many moles of NH3 should produce? 150. What is the mass of 1 mole? Now I use the formula triangle that N is equal to M upon Mr, and I want to find M, which is equal to N into Mr. N is 150, right? What is Mr? Mr is 17. So I find 150 into 17 is 2550. So how many grams of ammonia should have formed? 2550 grams, right? But how many grams do you actually get? 2.295. Considering that this ammonium nitrate was pure, what is the percentage yield? Percentage yield is 2.295 upon 2550 into 100. We look at the formula about 2. Or 2295, right? Because this both of them either should be in kg or in grams. So I'll take 2.295 divided by 2.550. That gives me 90% yield. Okay. Considering everything else is pure, this is the inefficiency of process in a way. This is how much I can get, right? If that makes sense, right? So this becomes part of reacting masses. Now you see that how did we establish the number of moles of NH4NO3, right, which gave us the number of moles of NH3, right? And from there we found out the Mr, the product, how much of the product forms, and from there we found out the yield. We use the logic of reacting masses. From masses, what did we do? Let me clean this a little bit. So I will show you what did we do. So let's, okay, no. Okay, finally I think, yes. So what did we do? We took the mass of reactants, we changed that to moles, right? 12,000 grams of NH4NO3 was 150 moles. Then we used the ratio, both of them were 1:1. Then we found out moles of product should be 150. If the ratio was 1:2, then the product would have been 300 moles. If the ratio was 2:1, the product would have been 75 moles. So accordingly we will do that, and we have a lot of examples coming and we'll be able to find out that way. Moles of product will give you the mass of product as well. You will be easily able to establish from moles, multiply the MR, right? Multiply by MR, you will find mass, and from mass divide by MR, you will find moles, right? So use the ratio from the equation, and this is how you find the reacting masses. Now, a lot of times our board asks that limiting reactants, what is the maximum yield that you can get, and in that they are hinting that you have to understand limiting reactants. Now I was talking about this when we started the discussion of this chapter. I was saying that let's say that carbon and oxygen should be in adequate amount for combustion to take place, right? The oxygen required in the example we have seen for ethanol, right? 3 O2 was required. If less oxygen is required, the products might change. Sometimes the reaction might not take place at all. And in that case, where the reaction does not take place at all, the one that gets over first is responsible for controlling the amount of products. And that is known as limiting reagent. The one that gets over first controls how much reaction takes place. That reactant is known as limiting reagent. So a simple example would be you have 10 slices of bread but only 3 pieces of cheese. The cheese limits you to only 3 sandwiches even if you have bread available for 2 more sandwiches. Okay, now there is a simple question for this, for us to understand this very effectively, right? We have 8 point, sorry, calcium chlorate 5 CaClO3 is made by reacting calcium hydroxide with chlorine gas. Achha. This 5 is valency of chlorine in this compound. Okay, not oxygen, not calcium, chlorine. Now, the reaction has been given, and if you observe, the reaction is balanced as well. 8.88 gram of calcium hydroxide and 0.3 moles of, I think it should have been mole over here, of chlorine gas are mixed together. How many mole in 8.88 gram of calcium hydroxide? Now, if you remember, you can easily find that out, that this was 40 plus 16 plus 2 into 2, right? So 16 plus 2, 18, 18 2s are 36, 36 plus, oh sorry, 1, 17 2s are 34, so this was 74, right? We have already found this out somewhere in the question above. So 74 gram is 1 mole, so number of mole is m upon mr, which is equal to 8.88 upon 74. So let's quickly do that. 8.88 divided by 74. You have 0.12 mole of calcium hydroxide and you have 0.3 mole of chlorine gas. Let's look at the next question. It says, what is the maximum number of moles of calcium chloride that can be made from 8.88 grams of calcium hydroxide and 0.3 mole of chlorine gas? Because we have not done the molar volume, I am writing it like this to make it easier for you. Now look at this question, guys. What does the question say? It says, what is the maximum number of moles? Whenever they say this, or whenever they have directly or indirectly given you mole of both the reactants, or 3 of the reactant or 4 of the reactant, it is always going to be a question about limiting reagent. They are going to ask you that which stops the reaction first. Now to do that, let us write down the moles of both of them. This is 0.3 mole and this is 0.12 mole. Which is greater? Clearly 0.3 is greater. So that must be your excess. The one that is limiting is less. The other one is excess. But a lot of times kids forget that there is a multiplier over here in this question, because this is the first question I am teaching it to you. I have kept the multiplier same, both of the places it is 6, so it will be easier for you to establish ratio immediately. But let's say this was 1:6. Then, of course, this becomes the limiting reagent. But what if it was 6:1? Then the other one becomes limiting reagent. I hope you're getting this. Let me explain the entire thing again. See, from the ratio, it is 1:1. So, how many ever moles of calcium hydroxide are required? That number of moles of chlorine must be required. Calcium hydroxide is 0.12 only. So, chlorine is 0.3. Only 0.12 mole of chlorine will react. The rest of it will remain unreacted because there is no more other reactant to react. In this case, what is the limiting reagent? Calcium hydroxide is the limiting reagent. Okay. So, in scenario 1, CaOH twice is the limiting reagent. But now consider this scenario where the number of moles are still like this, but the ratio in which calcium hydroxide and chlorine react is 1:6. So, 1 part of calcium hydroxide requires 6 parts of chlorine. So, 0.12 will require 0.72 mole of chlorine. Is that much chlorine present? No. So, in case 2, Cl2 becomes the limiting reagent, and therefore you should look at ratio, not just the number of moles when we are calculating the limiting reagent. Now, let's say instead of this, chlorine was in the ratio 6:1. Then what will happen? So, for 6 parts, 0.12 divided by 6. It will give you 0.02. Only 0.02 moles of chlorine is required to react. So, in third case, again, calcium hydroxide becomes the limiting reagent. I hope this part where how to understand the limiting reagent makes sense. So, let me quickly explain to you how to find out the number of moles of calcium chlorate that can be made from 8.88 gram of calcium hydroxide and 0.3 mole of chlorine gas. For this, you'll have to forget that chlorine, the one that is in excess, even exists. You have to then calculate everything from your limiting reagent. So, what do they find out? Maximum number of moles that can be produced. So, calcium chlorate, the ratio is 6:1. So, 0.12 divided by 6. That will give me 0.02 mole of calcium chlorate that can be made from this reaction. I hope this makes sense to you. What is the maximum mass of calcium chlorate that can be made from 8.88 gram of calcium hydroxide and chlorine gas? But because chlorine is unimportant, let's ignore it right now. So I have 0.02 moles forming, and calcium chlorate I think had a formula of ClO3 twice, right? So chlorine is 35.5 into 2 plus 16 into 6 plus 40, right? So I have 40 plus 71 plus 96. So 207. What did I do? I first found out the MR. Now I already have the number of moles, so I used the formula that M is equal to N into MR. This is the number of moles from the previous answer. MR is 207. So 207 into 0.02 gives me 4.14 gram of calcium chlorate that can be made from this mass of calcium hydroxide and that mass of chlorine. Now they are saying the experiment is repeated using different amounts of calcium hydroxide and chlorine gas. The maximum mass of calcium chlorate that can be made in the experiment is 4.84. The actual mass is 3.63. Percentage yield. So percentage yield is actual upon theoretical into 100. So let's find out. You have 3.63 divided by 4.84, and the answer multiplied by 100 will give you 75% yield. So in this process, the particular process that they're talking about in this question is or has a yield of 75%. Now we are going to discuss calculations with gases and solutions. Now, of course, gases are important because gases have a molar mass. Each gas that is at room temperature and pressure, room temperature is 25 degrees Celsius, pressure is 101 kilopascal. At this situation, every gas, does not matter if it's carbon dioxide, if it's nitrogen, if it's oxygen, it's fluorine. If I have 1 mole of gas, that gas occupies exactly 24 dm cube of volume, right? That 24 dm cube is also 24 liter. In a lot of questions, you will be asked to remember conversion, that volume is mole into 24. If 1 mole is 24 dm cube, 0.1 mole will be 2.4 dm cube, 100 mole will be 2400 dm cube, so on and so forth. So volume is mole into 24. Then 1000 centimeter cube is 1 dm cube, and 1000 centimeter cube is 1 liter as well. So 1 dm cube and 1 liter are the same thing. 1000 dm cube is equal to 1 meter cube. In some calculations, or at least in your AS and A levels, you will find equations that will require you to change dm cube to meter cube. It is good to understand that right now itself. And 1 mole is also 24 liter, because if 1 mole is 24 dm cube and 1 dm cube is 1 liter, and 1 mole is also 24 dm cube. Now we have a few questions that discuss these things, right? Now this will be combination of volume, this will be combination of reacting masses, this will also be a combination. We will, in the next coming questions, we will also find concentration. Concentration is nothing but mole upon volume. We'll see how it's important and how the questions are done. First, let's find this. When solid copper nitrate is heated, copper oxide, nitrogen dioxide and oxygen are formed. Copper nitrate reacts to form this thing. Calculate the volume of nitrogen dioxide formed at room temperature and pressure when 4.7 gram of copper nitrate is heated. Okay, so nitrogen dioxide they are asking, the ratio is 2:4 or 1:2. Just remember this, right? When you start with the question, try to find out the ratio you can. Calculate the mass of 1 mole of copper nitrate. Now copper is 64. I remember this. You can have the help of periodic table. There are 2 nitrogens, so 28. There are 6 oxygens, so 96. So I have 64 plus 28 plus 96 will give me 188 gram. Mass of 1 mole of copper nitrate is 88 gram. I hope I am not wrong. If I am, please let me know in the comments. So we have calculated the number of moles of CuNO3 used, NO3 twice, so we have 4.7 divided by 188. So I'll find that 4.7 divided by 188. The formula that I am using is N is equal to M upon Mr, right? We have just established Mr, measured mass is given to us. This will give me 0.025 moles. Sometimes written as 25 into 10 to the power 3 minus 3 moles. Okay, but you can write 0.025. Both the methods are correct. Determine the number of moles of nitrogen dioxide formed. Now what was the ratio? I told you that the ratio was 1:2, right? How did I find that it is 1:2? If you look at this, this is 2 and this is 4, so the ratio is 2:4, which can be written as, because it is ratio, it should be in the lowest whole number possible, which is 1:2. So the ratio is 1:2. That means if the reactant is 0.025, only double of that can be the mole of product, so 0.050. So the number of moles is 0.050, right? If 1 mole of copper nitrate gives 2 moles of nitrogen dioxide, 0.025 will give twice the moles of nitrogen dioxide. And now calculate the volume. I said that volume is equal to number of moles multiplied by 24. If you want to find it in dm cube, if you want to find it in cm cube, then you have to multiply it by 1000. But here the answer is asking you to find it in dm cube itself. So you have 0.050 multiplied by 24. That will give you 1.2 dm cube. This is the number of that is the volume of nitrogen dioxide that forms. The second question is concentration of solution and titration calculation. Now we've already discussed this, right? That in a reaction, if I want anything to react as quickly as possible, I need to get them to the particles of those reactants to collide with each other. Now we already know that we can increase the rate of reaction by making it powder, increasing the concentration. What does that mean? Concentration is when some solid is dissolved in a liquid and we find how many moles of that solid is dissolved in how much volume of that liquid. That is known as concentration. Concentration is mole of solute upon the volume of solvent. Concentration is mole of solute upon volume of solvent. So the unit is mole per dm cube. Concentration is mole upon volume. We have one more formula triangle over here. Right, so this is our formula triangle. Concentration is equal to mole upon volume. Mole is equal to concentration into volume, and volume is equal to mole upon concentration. Right? If that makes sense, then in this also again there will be a lot of questions which will involve changing centimeter cube to dm cube or sometimes dm cube to centimeter cube. I'll keep on explaining all of that as and when we see those questions. Now if you remember, in this text I had skipped the part which was emphasizing upon how I need to always write the state symbols. What are the states we know? Now that you know that there is concentration, the states we also know is aqueous, meaning the something that is dissolved, right? So we have solid, we have liquid, we have gases and aqueous. Now, the ones that are solid, you can find out from your textbook in, I think, chapter how salts are made. In that, there will be a list of salts that are soluble and not soluble. Generally, hydroxides are considered to be soluble, except a few. You will find them across your syllabus. So, let's say I think magnesium hydroxide can be considered as insoluble, right? Other than that, most of hydroxides are soluble. Most of oxides are also soluble until unless they will tell you which are not soluble. There will be some salts that are always insoluble. For example, zinc carbonate. All the carbonates except sodium and potassium and ammonium are insoluble. So, if it is insoluble, the state symbol is solid. Okay. HNO3. Acids we generally take in aqueous form. They are dissolved in a liquid. That liquid is water, which is why aqueous. Zinc nitrate. Now all nitrates are soluble. If it's soluble, then this is already taking place in a solution form and therefore aqueous. Water does not dissolve with water. Water is there with water, so it becomes liquid. Carbon dioxide is a gas. So these are the state symbols. This is how you write state symbol. Now if you notice, the reaction is already balanced because they have not given us blanks before the compound, which means the reaction is balanced. You can count for yourself. I know that the reactions are balanced over here. Now let's quickly get to the calculations. A student found that 2.5 gram of zinc carbonate required 20 centimeter cube of dilute nitric acid to react completely. Calculate the concentration of dilute nitric acid using following steps. So they will help us find the concentration. We have to just follow the step. Calculate the mass of 1 mole. Zinc I don't remember. Let me check. So how do I do this? MR of zinc. Zinc has a mass of 65. Okay, got it. So zinc has a mass of 65, carbon has a mass of 12, oxygen has a mass of 16. So you have 65 plus 12 plus 48, 125 gram. Calculate the number of moles of ZnCO3 reacting. So they have told us that 2.5 gram reacts. So 2.5 divided by 125, right? N is equal to M upon MR. So we have, what was it? 2.5 upon 125. The answer is 0.02 mole. Then determine the number of moles of HNO3 reacting. Look at the numbers. So this is 2, and of course nothing is written. It means it has to be 1. So the ratio is 1:2. Now, if 0.02 moles of ZnCO3 react and the ratio is 1:2, then easily the number of moles of HNO3 react is 0.04 mole. Then calculate the concentration of HNO3. I said concentration has the formula mole upon volume. Mole is already known, 0.04. What is the volume? I think they told us that volume was 20 centimeter cube. Now, can I write 20 centimeter cube as it is? No. I need volume in dm cube. How do I do that? How do I take centimeter cube to dm cube? So 20 centimeter cube is equal to 20 upon 1000 dm cube. Take this, replace it over here. You have calculator, you can easily calculate this. So 0.04 divided by 20 and that divided by 1000, right? So it gives me 2 mole per dm cube. The concentration of HNO3 is 2 mole per dm cube. Now, the equation for this reaction, for the reaction is shown. Okay, they are saying calculate the concentration of sodium hydroxide formed in gram per dm cube. Now, this is a very important type of question. So they'll ask you the whole question like we did in this HNO3 question. They'll ask you to find out the concentration in mole per dm cube. But then they will say convert this mole per dm cube to gram per dm cube. How do we do that? Let's look at this example. It will be very clear to you once we are done with this. Use the following steps. Calculate the number of moles of Na added. Now I think sodium has a mass of 23. Right, atomic mass 11, mass 23. I think this is the answer. This is the mass of sodium, but only 0.345 is used, so I will say 0.345 divided by 23. Now I will stop writing the formulas. You can assume the formulas yourself. If you don't understand, you can always ask in the comments. So I have 0.015 mole of sodium added, right? Then determine the number of moles of sodium hydroxide formed. So for that I will look at the equation, right? In this equation, what do I find? I find that the ratio is 2:2, or rather 1:1. So how many moles of sodium hydroxide can form? 0.015 mole. Okay. Then what do we have? Calculate the concentration in mole per dm cube. What is the volume of sodium hydroxide? 50 centimeter cube of water, right? So calculate when is added. Assume there is no change in volume, which means there is 50 centimeter cube of water present even after this reaction. So number of moles is equal to, concentration is equal to number of moles upon volume. Volume was 50 centimeter cube. So 50 upon 1000. I need to change that 50 to dm cube. When I put this in my calculator, I find that the concentration is 0.3 mole per dm cube. Now let's see what is the next part. Determine MR of sodium hydroxide and calculate the concentration of sodium hydroxide in gram per dm cube. Now MR of sodium hydroxide is 23 plus 16 plus 1, which is 40 gram. Okay. Now see, this is a very simple ratio. You already have 0.3 mole per dm cube. This is how many grams per dm cube. Do I have a method of changing mole to gram? I do. I just multiply moles with mR. So what I'll do over here, 0.3 multiplied by 40 upon dm cube as it is. So I will have 1.2 gram per dm cube. 40 into 0.3. Just a second, guys. Yes, it is not 1.2, it is 12 gram per dm cube. This is how you find out the concentration in gram per dm cube. Now, this is a neutralization question. Again, a repeated type of question that is generally asked. In this, we will have concentration of both the reactants and then we will calculate everything else that is required. Dilute sulfuric acid, right, reacts with aqueous potassium hydroxide to make aqueous potassium sulfide. Of course, neutralization is taking place, so water is formed. They have given this diagram, right? For our understanding, let us write the equation over here so we don't have to scroll a lot. 2KOH gives K2SO4 and 2H2O, right? I think that balances the reaction as well. Yes. What are they saying? They are saying that, see, 25 centimeter cube of aqueous potassium hydroxide. So calculate the volume of 0.0625 mole per dm cube dilute sulfuric acid that completely reacts with 25 centimeter cube of 0.1 mole per dm cube potassium hydroxide to produce aqueous potassium sulfate. Now the logic that we use over here is that using concentration and volume we can find moles, and the reactants are reacting with a particular ratio about moles, right? So it is 1:2. Okay. Now, so let's calculate this. First, they are saying use the following steps, so we don't have to think of sorry. So we don't have to think about this a lot. Use the following steps. Calculate the number of moles of KOH in 25 centimeter cube of 0.1 mole per dm cube. So I have number of moles is equal to concentration into volume, right? So concentration is 0.1 and volume is 25, but 25 is in cm cube, so divide by 1000. So I have 2.5 into 10 to the power minus 3 mole. See, now it becomes very easy to write this. You don't need calculator. So this is 2.5 and denominator can be written as like this, minus 3 mole, right? Deduce the number of moles of H2SO4 that react with KOH. Of course, it is going to be half of what KOH is, right? So this answer is going to be 1.25 into 10 to the power minus 3, right? I hope this makes sense. Okay, they have given a lot of space to do that, but it's just ratio. Calculate the volume of H2SO4 required. Now, what is the volume? See, concentration is equal to mole upon volume. Volume is equal to concentration, mole upon concentration, right? Moles required is 1.25 into 10 to the power minus 3. Let us also have a look at the concentration of H2SO4. The volume of 0.0625 H2SO4 is sulfuric acid. The concentration is 0.0625. Let's write it down here, 0.0625. Okay, that will be the volume in dm cube. This volume is going to be in dm cube. So 1.25 or yes, 1.25 into 10 to the power minus 3 divided by 0.0625. So you have the volume is 0.02 dm cube, but they are asking in cm cube. So multiply this with 1000, you have 20 centimeter cube. Okay, I hope this is clear now. Now, they are saying the experiment is repeated using same volume and concentration of potassium hydroxide, same volume and concentration, same concentration of dilute sulfuric acid. But in this second experiment, the product is aqueous potassium hydrogen sulfate. Use your answer in C1 and the equation to deduce the volume of H2SO4 required. Now the ratio is 1:1. Okay. Now if this is still the concentration, of H2SO4 to neutralize, if they are in equal ratio, I can say double volume will be required. Right? I'll repeat this again. When they were reactant ratio 1:2, how much ever this was there, 20 centimeter cube of H2SO4 was required. But now the ratio is 1:1. So if 20 was required before this, now almost equal will be required, right? In such a way that the number of moles become equal, right? To understand that 1:2, right? Let me also write this down. When it was 1:2, then see, this does not actually matter right now. This is okay for us to understand. When it was this situation, this was 20 centimeter cube required when you use 25 centimeter cube of the other thing. Okay. Although the ratio is not for just volume, I'm just explaining it to you. For 25 centimeter cube, half of it, 20 was required. But now, if they are reacting in equal ratio, so for 25 centimeter cube, 40 centimeter cube must be there. Only then all of this reaction will take place. So your answer is 40 centimeter cube. Now we have established every small detail that is required for you to crack this concept. There are a few exam tips and conclusion that we can draw from this chapter, and then we can end the discussion of this chapter. The first thing is that the idea is this, right? For the entire chapter, if you think about it, this is the main idea, that the mole of reactant, use ratio and find the mole of product. If you can understand this much, you can find out any way in which you can reach your answer. So let's say they have given concentration and volume of reactant. You can use volume and concentration, find out the moles. From that, you can follow this method. Let's say they have given you mass. You can then divide it with MR and again go through this. If you have just volume, divide that volume by 24 and you will have mole. Once you have mole, you can again start this. Now with the product, if they have asked you volume, multiply it with 24, you will get mass of the, volume of the gaseous product. If you then divide it by MR or multiply N into MR, you will find out the mass of product. And if you have volume, you can also find out the concentration of product. So the idea is only this much. Moles of reactant, use ratio, find out the moles of product. Other than that, it requires you to remember a little bit of formulas. But if you're not good at formulas, if you're not that good at chemistry, if you are good at ratios, you should be able to easily crack this chapter. What are the things that you should remember? Always start with the balanced chemical equation. Show your working clearly, step by step. Formula, what values did you keep and how did you find your answer? Watch your units. As I said, centimeter cube, dm cube, kg and gram, right? If given amounts of two reactants, check for limiting reagent. Always, if both the reactants amount is given, one of them has to be a limiting reagent. They will not tell you that it is a limiting reagent question, but still can be a point to remember. Remember, at RTP, 1 mole of any gas is 24 dm cube. And if you are better at math, use ratio. If you are better at chemistry, use this. Right? I think I will attach a mind map of this chapter in the downloadable PDF for what I have explained so far. With this in mind, Thank you for watching this video. Keep coming back for more lessons. Download our app for worksheets, for other videos, I think question papers or video solutions of difficult doubts, or announcement of live sessions, or announcement of new online batches, anything. Keep in touch. Thank you for watching. Bye bye.